Great, so we're here at the IBC Summit in Istanbul. Very excited to be here as an IBC Maxi. I was anticipating this panel the whole week. I should probably take off this competing interoperability protocols, non-IBC protocol t-shirt. That was not appropriate. Apologies for that. Interchain, much better. So before we get started here, I'd like you to both introduce yourselves and talk about what you're building.
Yeah, so I'm Karel, CEO of Union Labs. We do ZK consensus verification, and I'm basically focused on bringing IBC connections to Ethereum for Cosmos chains, and after that, IBC connections to rollups and other L1s. We came out of stealth about 3 months ago with the first live IBC implementation to Sepolia, Ethereum's testnet, and have been running transfers since then.
Does this work? Oh, nice. Hey, my name is Bo. I'm a co-founder at Polymer Labs, and we're working on bringing IBC interoperability to Ethereum rollups.
Cool. So Polymer and Union share a similar vision. And since I think a lot of people in the space maybe see you as competing products or projects that are working on a very similar vision that are somehow sort of like competing for a narrative, I'd like you to describe each other's project.
All right, so that's a bit harder for me right now, I guess, since you guys just pivoted a little bit ago. To describe Polymer, you guys basically created the modular market for IBC. I guess over the last 2 years, you've really brought on this idea of the need for the standardized protocol to Ethereum. And now I think you identified correctly the way to solve this for optimistic rollups, which are an absolute pain to be able to bridge to trustlessly because you get basically 0 guarantees whatsoever. So from that, Union has taken a lot of inspiration and has followed you guys along your journey.
Oh, thank you for the kind words. I think we've been thinking really hard for the last few years. From my perspective, looking at your guys' work and the short journey that you've taken in the public's eye, it seems like you guys are working, have a deep focus on the ZK side, and also like ZK consensus proof verification. I know there's maybe a few other companies also working on that, but I think verifications such as ZK verification or efficient verification of different consensus mechanisms is really important for the space, and obviously, like anyone working on expanding the IBC network, is a part of the same family. So
that was very good. I learned a lot about Polymer and Union right there. So what's the biggest challenges that both of you are trying to address, and where might your work overlap?
So right now for Union itself, focused on bridging to and from Ethereum, we get pretty strong guarantees on the consensus and the finality of the system itself. But we work in very gas-constrained environments. So it's all about how efficiently can we do these IBC operations, because we need to be competitive with layer 0, wormhole, and make sure that the UX is going to be good. I think for Polymer, you guys exactly the opposite right now with your focus on rollups. You've got a lot more gas to spend on doing operations, but your consensus guarantees are now a lot weaker.
Yeah, I think as Karel mentioned, when we go from I guess like Polymer back into the Cosmos side, now we need a additional client to kind of represent 1, Ethereum consensus, and 2, the optimistic rollup itself. And be able to parse that. And in this case, that being Polymer, because Polymer forms a connection with a Cosmos chain, and also with another rollup. So there's some connectivity issues there. And then on the gas side, most of our costs now are settlement related. Previously, when we were building an IBC connection and also like a ZK IBC connection, the dominating cost was the cost of that client update, roughly $300K or $200 30, 40 to 300K, depending on how you implement it on Ethereum at some clip, which can be quite expensive.
Do you guys do fraud proofs as well for your optimistic rollup, and what system are you guys planning to use? I didn't follow that.
Yeah, currently our approach is to continue using what Optimism has done with Canon. So we have one engineer kind of experimenting with interactive verification games. It seems like you can essentially cross-compile any Go program, any arbitrary program, and be able to prove the it's like fraudulent competition or like a misstep in the program. You change the opcodes from like all the Go instruction set, and then you kind of change it over to like the MIPS or RISC-V as I mentioned in my talk. We're using the MIPS-based fraud proving system right now, and have been able to do some successful challenge games, and it needs to be extended to other connected chains.
There's one thing I don't really get into the system. Sorry for derailing.
That's cool. You can you want to moderate?
Yeah, for settlement of your bridging transactions as a bridging hub, then do you not need to also wait for Polymer's fraud window to close before you can actually settle those IBC transfers between rollups?
Yeah, so like Polymer lags behind. I see it more as like a sliding window. So like if you have one optimistic window, let's say it's 7 days, and obviously at the beginning of the window you have the time to data availability, the time to the finality on the L1, the time to when you actually submit the proposal on chain, and you take that sliding window and I kind of just stack like Polymers next to the rollup itself. Sorry, I want to, and because the sliding windows are almost like mostly overlapping, the additional latency is relatively small. So like as the rollup that's connected is producing unsafe blocks, Polymer is also producing unsafe blocks, and those will be resolved down as shortly after the blocks on the connected rollup side gets resolved down. But yeah, that's a good distinction to make. It's not like we're not like stacking them like one after another sequentially.
So I'd like to maybe just reel it back to IBC here, since we are on IBC to Ethereum. I mean, I appreciate the technical deep dive, but I want to keep it a little bit high level here. So I mean, coming from the Cosmos ecosystem, IBC is sort of enshrined in the tech and enshrined in the narrative and enshrined in that ecosystem. But it as of yet, it hasn't reached Ethereum yet. I think from what we've seen here today, we can expect that in the coming months and years that will solidify, and we will see more IBC interconnectivity with EVM chains in that broader ecosystem. What is the biggest challenge there in making IBC compatible to Ethereum? Like, what is the sort of key issue that prevents that from working out of the box as it does in the Cosmos space?
I see it as less of an engineering problem, because like I think to do the engineering work to just implement IBC within the context of like Geth or within the context of these, it's doable. Like, you can do it. The issue the bigger issue that I see is, I think, especially on the Ethereum side and even on the Cosmos side, people have like a misunderstanding of what IBC is, and it starts with everyone thinking that IBC is only like consensus-based light clients, or it's just a light client header relay. I think that misses the point of like, if you want to design a protocol for asynchronous communication between either processes or chains in this case, there needs to be some like established rules, and either you have less rules and you force the application to implement more, or you implement more rules that are generalizable across applications, so the applications don't have to do it themselves. There's a trade-off between the two, and I feel like a lot of interop protocols in the Ethereum space just trade off heavily on the side of like, this is just an open broadcast and we don't have authenticate, we don't have anything. We just like, you just send a message, we just broadcast it. There's no additional guarantee, or there's no additional like functionality around like, what if it actually doesn't reach the destination? What if there's not enough incentives? They're just like, if you put a message in our queue, we guarantee that it'll just be delivered.
Yeah, that's actually how our team started out as well, by wanting to build lifeline-based Interop, and then realizing that to handle all of the edge cases properly, you in the end start to re-implement IBC or do a worse version of it. So indeed, handle all of these edge cases, acknowledgements, etc. properly, you're going to need to do it in a certain amount of handshakes, packets, acknowledgements, etc. I think if you want to like handle all these cases over layer 0, for example, you would almost identically be doing IBC with then another verification client. And I think that's like very missing in the Ethereum ecosystem right now. We haven't seen it gone wrong yet, even though we have a lot of centralized sequencers, a lot of protocols that just blindly trust these broadcasts. But if we're going to see like a chain reorg of a rollup, that could lead to like loss of funds, double spend attacks by the sequencer. I think that's what's most interesting about like bringing IBC to the Ethereum stack now, is to start thinking about, if we're going to scale to thousands of rollups, there's going to be a few malicious ones in there. Can we have an Interop protocol that actually identifies these and properly handles the malicious behavior?
How is that different from how chains within the IBC ecosystem, i.e. Cosmos SDK chains, handle that?
Yeah, so in this case, IBC in the spec itself has different mechanisms for detecting this, for proving that fraud has occurred in a chain, for ensuring that not only like do you lock up your funds on one chain, but they actually arrive on that other chain, right? Like if you're using layer 0 right now, your contract is going to emit an event and your tokens are going to be locked up, but there's no guarantee that your tokens will arrive at the destination. You're completely trusting the relayer in between, and you're also trusting the relayer to refund you your tokens in case something goes wrong. But there's no actual on-chain mechanism for ensuring this refund happens. And in the case of IBC, there is an on-chain mechanism for doing these refunds.
Okay, thank you. So I'd like to maybe shift to Polymer for a moment. So you just gave a presentation about the shift in direction for Polymer, and we talked about this a little bit earlier. Yeah, can you describe basically what this shift means in terms of the product, and also the sort of your specific way that you're tackling interoperability from, I guess now you're sort of like moving more into the roll-up interoperability space?
So we've been thinking for quite a bit of time on how exactly do we get IBC distribution in the Ethereum ecosystem. And we kind of felt like, especially seeing how the Ethereum roadmap progresses, that the likelihood of getting it like into the L1 itself is probably not high. On the L2 side, I think that's like a lot more. It's a lot more likely, and in fact, like us going out and putting the Cosmos SDK itself, which has native IBC interoperability on top of the OP stack, we felt was probably the biggest distribution tool for IBC on Ethereum. The hub is great. It does allow us to enable like non-native IBC interoperable rollups, but bringing that native IBC interoperability to the rollup ecosystem, and hopefully pushing for builders to build using that can allow us to get the distribution that we need, and also the mindshare that we need. Otherwise, I feel like when I chat with certain Ethereum folks, it's kind of like IBC is like this term, and they're just like grasping at it. Like, oh, I've heard about it. I don't know what it is. It's just like somewhere in the ether.
And is any of the work that you've done previously on because I know previously you're working on the ZK Tendermint consensus, is that work relevant to this shift in direction?
So it's not relevant. We did have to, I guess, had some work that we had done that we're not using anymore. But I think it's useful it can be useful in other contexts. So we didn't implement it. So we had a POC implementation of ZK Mint. We spec'd out a production version because the POC version we had to fork Tendermint, and that was really annoying because we changed validator definition, and by changing that, all the tests are affected, all this other stuff is affected. So we had a spec for how we'd implement using ABCI++. I think that could be interesting because you can adapt that to like doing BLS. So like you don't need a commit fork. You just implement BLS as an SDK module over ABCI++, or like some other I guess like header optimization method.
Yeah, I think this is kind of what we're saying, where it's feasible, but it takes a lot of engineering work. With Union, we did go with the approach of starting out with a fork, fixing up a lot of stuff, and basically just grinding out thousands of engineering hours to actually make such a system work, which in the grand spectrum of like research isn't that interesting, but for purely as an engineering challenge is actually quite hard to accomplish. And I think that so far also for IBC to Ethereum has been a limiting factor. Cosmos SDK is great, but by now it's quite old. And that doesn't mean that the tech itself is outdated, but if you just got a very large software project, at some point there's assumptions built into it. And there's a lot of assumptions around Tendermint in the Cosmos SDK, which we basically had to remove and work around to make the system work. And I think IBC right now is actually generalizing really well and allowing for connection to completely other L1s or even rollups.
I might oversimplify here, and please tell me if I'm grossly misrepresenting this. But from the recent shift of Polymer, it sounds like Polymer is positioning itself as a hub that sits in the middle of sort of the roll-up ecosystem that provides a link to the Cosmos ecosystem via IBC, but also IBC connections to each of those roll-ups. While from the conversation we had recently on the podcast, Union is an IBC connected Cosmos chain that connects to the Ethereum ecosystem and provides a way for chains to send messages to the IBC ecosystem. So it's sort of like one hub is in like one side of in one domain, and the other is like in another domain. Is that a correct representation?
Yeah, although we're not necessarily focused on just the Cosmos ecosystem, I think the big difference is we are focused on every rollup or chain where we can do light client verification, which means that optimistic rollups basically don't work for us, as well as that we can integrate more closely with rollup as a service providers. And I'm more focused on actual provability.
Okay, I got it. So what's so difficult about interoperability with rollups? You mentioned this earlier.
Yeah, I mean, a rollup is basically just someone's computer that speculatively executes transactions and at some point checkpoints on Ethereum. Ideally, you want to bridge out of a rollup before checkpoints, right? Like fast exits, fast entries. But there's no guarantee that the sequencer is actually going to like abide by what's it be broadcasting in between. It might, during checkpointing time, checkpoint a completely different history. And this allows a sequencer to perform a double spend attack, which is basically bridge out of the sequencer, change the history, and now the sequencer holds funds on both the sequencer and the L1, and the bridging protocol loses the funds. So far, we're not really seeing this because these big rollups are so massively valuable that performing this attack would destroy their reputation and destroy a lot more value in their token and such. But if we're going to this world of many rollups with rollups as a service, sequencers and such, then we're going to see smaller market cap rollups. And then it might actually be feasible to perform this attack and make more money by rigging the bridging protocol over the value that the rollup itself holds. And so that's like the biggest problem here. Very much akin to kind of like plasma channels, lightning network, like it's all kind of the same space with how do you do this securely without trying to settle and avoid doing these checkpointing operations.
You want to take a stab at that too?
I think the problem of bridging rollups varies depending on where the rollup lives. In my talk, I talk about rollups that live on Ethereum. There's 3 different heads. Unsafe head, which you definitely shouldn't use to bridge because it's unsafe. Data hasn't been made available. You basically have no guarantees. The safe head, where the data has been made available, and then kind of like the finalized head, where that data is finalized on whatever connected chain you are on. I think with the modular paradigm, it makes it a little bit easier, since now you can say I can use like a Celestia, I can use like an INDA. And with those solutions, you can have faster time to finality for the data. That doesn't prove validity though, unless you bundle in a ZK proof for a ZK rollup, that would prove validity. But for like an optimistic rollup that doesn't prove validity, you would have to rely on something else to prove the validity of that state transition. But you can get, I think, decent UX with like reasonable guarantees in the modular paradigm if you just plug in play the right Legos together. Yeah.
Yeah, I think this is where like IBC shines as well, because we have standards like rate limiting and such. Yeah. So it's not necessarily about like being 100% secure. It's about putting a number to the risk. And with bridge hacks, we've seen like 1.6 billion being hacked. That's way too much. But if at any moment only 150K USDC of funds are at risk in a 100 million protocol, that's a very acceptable risk overall, and to be honest, completely negligible. So I think we're going to head to that with the modular kind of ecosystem interoperability thesis, where there might be at some points certain amounts of funds at risk, but not worth actually doing a double spend attack over.
Yeah, it's actually interesting seeing the different standards evolve, because in IBC land, you have the concept of a channel, which, if when you establish a channel for token transfer, that specific standard, that channel is dedicated to token transfer. Nothing else flows over that channel, because you're binding the two, I guess like ICS-20 modules on each side.
Okay, interesting. I didn't know that.
Whereas like with existing protocols on the Ethereum side, everything goes through like the same channel, that's a very different security risk. You don't have fault isolation. In addition to make it even worse, like I'm not like shitting on the designs there too much, but what I don't like about what's going on the Ethereum side is like they've gone this path of saying, okay, well, why don't we just aggregate all the bridges? And I'm like, well, like, okay, you're aggregating like 4 different security models for like the same token, and you're putting rate limiting behind them, and now you just have like, okay, this could be there's a 10% chance that this will depeg by 30%, and maybe like a 20% chance this will depeg by like 40%. If there's like really weird kind of security models, where with IBC it's very clean. You just say, this channel is established over this connection is secured by X level of security, and you have those guarantees. So if this security doesn't get borked, you're 100% safe. Or if the security gets borked, you're basically like unsafe. But you allow that channel, the owner of the token over that channel to kind of alternate between these security models by upgrading over these connection IDs. So I kind of like the IBC standard approach versus the what we're seeing in like the Ethereum side with like multi-message aggregation and these other XERC20, these other standards.
Cool. So Celestia just went live last week, and there are like that narrative is finally coming to reality. You know, the modular narrative. I think interoperability is a big part of that as well. I mean, if we're going to have a world where there's thousands of chains, right, in the form of rollups, we need to have better interoperability solutions. I was just at the Modular Day event yesterday and did an interoperability panel there as well. And Hyperlane was like a big player there in that space. Obviously, currently Axelar plays a huge role in bridging Ethereum to Cosmos, but also Solana and other ecosystems. Now, these are two very different products, right? I mean, like one I think resembles IBC more so in this sort of like peer-to-peer construction. It's also like modular, right? I'm talking about Hyperlane, whereas Axelar is more of a hub and spoke model. So there's advantages there in terms of being able to pool liquidity, et cetera. You guys are both working on the IBC specification. These protocols are working on, say, like I would call them more like permissioned, I guess, in the sense where they're more like interoperability products, less so than working on a spec, right? Building on top of a specification. Do you agree? And then my other question was like, how do you compete with these products that are very feature specific and are have like tons of funding, have already amassed like lots of users, applications that use them, etc.
Yeah, loads of questions in there.
Sorry.
Yeah, no worries. So I'm very conflicted about Hyperlane because Hyperlane, in essence, like is a set of contracts that you can use permissionlessly, meaning they're MIT licensed. But in the end, you're still going to run a bunch of validators or a multi-sig to perform the bridging operations. And we've talked about fungibility before. Such a system cannot be fungible because if I join the Hyperlane network with my rollup, that means that I could have my like multi-sig relayer commit fraud and mint assets. So you always have to isolate risk in such a system. Axelar, hub and spoke model, but doesn't need to isolate risk because they have a global view through their chain, but doesn't scale well with number of connected networks because each validator needs to run a full node. So 40 connected networks times 100 validators becomes 4,000 full nodes, which doesn't work well in shared security models and such. Competing with users and what protocols want to use. On Union side right now, we see a lot of interest coming from parties that hold large amounts of funds that want to chase down yield in other chains, but so far have both the bridging risk and the DeFi risk, which is together too high to actually commit to bridging. While with Union, we actually take away part of the bridge risk, which means that now they can actually bridge to, let's say, Osmosis to chase down yield on STETH. So that portion is kind of what we're going for, a more bespoke model instead of chasing down retail users. What I think is probably going to happen is with more apps adopting IBC, direct integrations into the apps themselves. Something like Plate, which does the open finance in the banking standards, standard APIs that allow anyone to create a fintech company and integrate in the wider ecosystem. And with that, we're going to see people no longer being centered around the bridging protocol, no longer going to bridging.union.build, but instead directly in their DEX or in their yield staking app, select from multiple wallets and have the bridging operations occur under the hood. That's kind of this modular future that we're looking for. We're no longer aware of which chains hold the protocols, but instead you just integrate with products directly.
I have a interesting perspective. Well, maybe it's interesting. I'm not entirely sure. So one, I don't think that IBC is necessarily P2P specifically. I think it could be P2P. It could also be hub and spoke. Like once multi-hop IBC channels is enabled, the Cosmos hub could be a hub. Celestia could be a hub. And then on the Axelar Hyperlane IBC comparison side, I feel like I could see them merging over time. Although like I don't think that that's Hyperlane's intention. It feels like their intention is to replace the IBC network with their own, with like they took out all the core messaging logic of IBC and specification and replaced it with nothing, and for simplicity and lower gas costs. But obviously that's not great. I think that a solution like Hyperlane or a solution like Axelar could actually just plug into the IBC network. They could plug in as a solo machine client, have respect like IBC semantics while also still doing their own verification, which that's what they're doing anyway. So like I don't necessarily see why they would need to like grow their own network versus just kind of extending the IBC network. Obviously for business reasons, they have to do what they have to do.
Yeah, I mean, so in I guess what I'm hearing here is that there's a moat, right? I mean, they're trying to create a moat around interoperability. When building on IBC, I often compare IBC to to the SMTP protocol, right? Like you can use SMTP with Firebird, or you can use it with Google Gmail or whatever, and you can like move your emails from one to the other. Touching on the topic of fungibility, is that the case here? Like, are competing products that are building on IBC, can they be fungible in a future where we're able to prove the provenance of funds through some sort of like? I'd like you to maybe dive into this example a little bit, but yeah, is that compatibility possible even though you're building different products?
I think that's probably kind of the hottest topic for IBC in the coming few years, is actually making these assets fungible, handling multi-hop routing properly, and basically the diamond transfer problem, where if you transfer the same assets through two different chains, you right now end up with two different assets on your final destination, which for UX is just absolutely terrible. And we need to do like path unwinding, allow skip protocol to have a nice product where they do this for you. But in the end, it's not actually the interoperability that we're looking for. Just to be clear, like this lack of fungibility is a security feature at the moment. It's specifically designed into IBC to isolate risk. So what we need to do to actually be able to make assets fungible again is somehow increase the security and basically be able to show that assets through different chains are coming from the same provenance, which there's loads of different solutions where you can accomplish this. Could be some form of ZK fraud-proof model where there's an amount of assets at risk, but only a small amount at any time. Could be a model where instead of doing like lifetimes updates with just a consensus of a chain, we also include how the chain got the original assets. And then you kind of get like this recursive proof structure where for every chain, the proof contains all transfers going in previously, and you keep on building from that proof. That's kind of what I think is the coolest solution to this, because that would mean for any bridging transaction, the proof implicitly always contains all of the previous bridging transactions. That right now would be possible. The downside is that's computationally very expensive to accomplish. So I don't think we're going to see that in the next few years, but I have my hopes up for that.
Yeah, I think just to add on to that, proving validity is one factor, but proving the actual ordering of the transactions in the block is usually achieved by consensus of the network, or if it's like a sovereign rollup, then that fork choice rule is implemented by the connected bridges. Every bridge kind of has a subjective view of what that chain is, and that changes depending on where you're connected. But obviously, like some rollups, they will specify that fork choice rule in some place, or if they're like an L1, the L1 itself is specifying the ordering or attesting to the ordering.
Cool. I mean, I can't wait till the day that we have fungible assets and these bridge tokens are no longer a thing. I think it would be great for user experience. I mean, obviously, it fixes a ton of user experience issues. So maybe to end on here, looking forward, 10 years from now, 2033, when using an application, when a user is using, say, like Uniswap, if Uniswap's still around, then what is that going to feel like when they're moving, tokens when they're swapping tokens from Uniswap into, say, Atom, like swapping ETH for Atom once Uniswap has adopted IBC, and that's possible.
To me, at least, what this means is that you're no longer aware on which chains these apps are at. And you just integrate with the protocols directly as a user, completely unaware that one is backed by Celestia and is a rollup, and that the other one is an L1. And that's kind of what I want, because I'm sick of having 20 tabs open.
Yeah, like once we have a unified API, technically, theoretically, I mean, there's other factors. The experience should be consistent. And hopefully you have like, wallet integrations over this consistent API. You have like custodian integrations over this consistent API. And yeah, users don't have to worry about the chains.
Great. I think that's a future we can all look forward to. Thanks so much, Karel and Bo. Thanks for doing this.
Thank you.